Hey CTM students and anybody else that may be watching, welcome to the Chapter 9 practice test. We're going to be looking at the geometry problems here in the Chapter 9 practice test. Remember, there's also extra problems in the book on the pages previous to this. It's 554 to 556. You've got those pages for extra review if you want to use those. This is just going to be the problems from 9.1 through 9.4, and I may make a second video later on, but I'm just not going to do that right now, to do kind of a part 2 of the Chapter 9 practice test. But for right now, I'm just going to be doing problems 1 through 13, 14 through 21. Again, I may be doing at a later time. So let's get started with number 1 here. So in exercises 1 through 4, use the figure to describe the following sets of points. And this right here is a half line. I may or may not have assigned this one to you. Just check your assignment sheets if you're one of my students. But a half line means it doesn't actually include the point right here. I'm going to draw some stuff on the picture that I will erase a little bit later, but I'm going to draw here the half line AF. So I have F or A, it's not including that point, but it's everything going towards F after that point. So it's going to have all that stuff from A but not including A all the way this way. And then EF, I'm going to put that in green. That's going to have this point, but not actually including that point, but it's starting there just to the left of that and then going in this direction. So they're both heading in the same direction. They're both going from the initial point to or through F. But if we're talking about this is the intersection. What do they both have in common? I will highlight over that what they both have in common here. They don't have E in common because this half line does not include, the green half line does not include E, but everything after E they do have in common. And so that's what we're looking for. What's the intersection? What do they have in common? So it's not including E, but everything to the right of that. So what's the answer to this one? The answer to this one then should be half line E F. So we put a little open circle above there, make sure it's clear that it's open and not filled in. So half line EF for that one. And so let me erase that stuff there, and let's check out number 2 from there. Just getting rid of all that stuff. All right, number 2. Now we're talking union. So it's what's on either one or any of them. Everything gets included. Whatever is in the picture gets included. So BC, segment BC, we've got from here to here. We're including the points B and C. In green, I'll do the next part. So this was in red, segment BC. In green, we'll draw CD on the picture. So CD will be from there to there, including the points in between. And then in blue, I'll do this part, BD, will be here and here. So what I'm saying here with the union, though, is anything and everything that's any color. It doesn't have to be stuff that's on both of them. So anything and everything, anything that got hit at least once by any color, that's the union. So it's everything there. It's this particular triangle, so we call that triangle BCD. We can use a special symbol for triangle. Use red there we go. And it just looks like a miniature equilateral triangle, but that's a symbol for triangle. So triangle BCD. I'm not saying that this is an equilateral triangle. I'm just saying that the symbol looks like that for triangle. So BCD, you could say triangle CDB or CBD, CDB or CBD. I think I said the same thing there. You could use the letters in any order, put the letters in any order. You'd have the right triangle. It would be the same triangle. Okay, let's get rid of that now and focus on number 3. Number 3, we have angle EDF and the intersection of that. So what do they have in common? In other words, EDF, I'll do that in red. EDF is right here. So it's kind of starting at E, going to D, and then going through F. Yikes, that was not a good line right there. So it's going that way and going this way. That middle letter is always your vertex of the angle. It's always the point from which the rays emanate. And then angle BDC would be here. That's the middle point again. The middle letter is the vertex. They're coming out of there The rays are shooting out of there, and we're going in that direction that way. And so this is intersection, so what do they have in common? Where are they meeting up? And what's both blue and red? In other words, only that particular point, point D, is both blue and red. So you would say point D, it looks like the back of the book is saying that in set notation. It's using something like that. That would be totally acceptable as well. So you could just say D or point D or D in the fancy brackets like that, the set notation brackets. I would take it any one of those ways. And finally, number 4. Here we are talking about ray AC, so it includes the point A and goes in the direction of C. It goes on forever that way. That was in the red. And then ray BA, that's that point right there, point B. It goes on forever in this direction. But this, notice, is union. So it's what's either color. It can be both colors or it can just be one color. But what is included on either of those colors looks like this whole line. Line AB or line BA, you could say, equivalently would be included in the union of those two things together. So this answer would be line AB. You could put the line symbol above it like that, or you should put the line symbol above it like that. It looks like the book says line AC, which is the same line. So line AC would work. Or you could also say line BA or line CA. We can flip-flop the order of the letters with lines. You could even say line BC or line CB. I don't know if I want to write all of those. I guess I will. Might as well. These are all acceptable answers. They all describe the same line. So any of those answers would be correct answers right there. They all describe this yellow highlighted line, which is the union of these two rays. Moving on now to number 5. Number 5 is saying that the measure of an angle, angle A, is 36.9 degrees. Determine the measure of the complement. Complements are supposed to add to 90 degrees, and then this one talks about supplements. Supplements are supposed to add to 180 degrees. And I want you to think of this to remember it. There's other ways you can come up with too. I've had a lot of my students in the past come up with some pretty clever ways to remember, but I think the easiest way, at least for me, is just to remember that C comes before S in the alphabet and 90 comes before 180 on the number line. They go together in that order. So C before S, 90 before 180, complementary before supplementary. But if they're supposed to add to 90, all I need to do for this one is take 90 and subtract 36.9 from that. That's very close to 37. If I subtracted 37 from there, I would have 53, and an extra 0.1 from there, I'd have 53.1 degrees. So that's the complement of an angle with that measure. The supplement of an angle with this measure, I'm taking 180 and subtracting 101.5 from that. So this minus 102 would be 78, so an extra half off of that would be 78.5 degrees. Just trying to work on our mental math a little bit here too at the same time. Number 7, in this figure, determine the measure of angle X. So here's angle X, kind of playing, you could call this, I've heard it called the angle game before. What do we got here? So we've got a bunch of different angles. It looks like this angle right here, I could use the fact that 180 minus this angle would give me this angle. I have a linear pair right here. They are supplementary to one another. So 180 minus 48, that's going to be this angle right here, 132 degrees. Now that doesn't give me what this is yet, but I'm getting closer now. So I'm going to do, in blue, I'm going to do this one now. That I have this one, I can figure out this one pretty easily. I can just do 180 minus 132. That looks like that would be 48. And you may have noticed something, or you may have been yelling at your computer screen there, Mr. Wagner, you're doing unnecessary work. And I would agree. I did something I didn't need to do there because I have vertical angles right here, and vertical angles are always congruent. So this angle wasn't really necessary to figure out. But hey, I did it. I caught my mistake too late, or my unnecessary work too late. It wasn't really a mistake, but that's okay. 112, what's going to be here? They form a line together. 180 minus 112. That would be 100 and, or not 100, it would be 68, not 160. So 68 degrees. So now we have 68 degrees here, 48 degrees here. What's left for x would be 180, because you have a triangle right here, notice. Got a triangle right there. And all the angles in a triangle, the interior angles, are supposed to add up to 180. So if we just subtract the sum of 48 and 68 from 180, that should give us our answer for this one, for number 7. This would be 180, I'll put it down here, 180 minus, and it looks like that would be 100 plus 16, so minus 116. That, my friends, should be 64 degrees. So number 7, 64 degrees is our final answer. Time for number 8. Number 8 says to determine the sum of the measures of the interior angles of an octagon. So there's some different formulas you should know. You should review your notes, of course, as always, to get ready and to prepare for the test. Not everything you see on the practice test is going to get covered exactly the same way on the real test if you're one of my students, but a lot of crossover there. You got to know your stuff here on the practice test from your classwork and from your notes. If you understood that stuff and understood it well, as always, you should be good to go for the test. But determine the sum of the measures of the interior angles of an octagon. So the sum of the measures of interior angles in general is always n minus 2 times 180. Remember that we can draw, this is just some general shapes, but we can draw any types of polygons. So I got a triangle, I got a quadrilateral, I've got a pentagon, I've got a hexagon, and so on. And remember, we can split those up into one triangle. We can split it up into 2 triangles. We can split it up into 3 triangles. Notice it's always 2 less. The number of triangles you can make is always 2 less than the number of sides you start with. That's where this comes from. N minus 2 times 180. Each triangle is 180 degrees, and you can make n minus 2 of those triangles no matter how many sides you have. So from here, what's our n? Well, an octagon, we got to know what those are. We got to know how many sides. So you got to know your triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. That's up to 10. And then you skip to 12. You need to know that one, dodecagon. And you also need to know 20 is an icosagon. You got to know those ones specifically by name. The other ones, yes, there are names for them. Some of them are pretty crazy names. If you wanted to learn those special names, you could, but those are the only special names we need to know, what I just listed off. But an octagon has 8 sides. It's like a stop sign. And so we can think about it visually. If that helps you, I'll draw a picture here. Here's an octagon. How many triangles can we split that up into? You can split that up into 1, 2, 3, 4, 5, 6. So you got 6 triangles. But again, we're just using this formula. It's 8 minus 2 times 180. So in other words, it is 6 times 180. 6 times 100 would be 600. 6 times 80 would be 480. Put those two things together, and you've got 1040. So the final answer for number 8, 1040 degrees. I said 1040. What am I saying? 1080. I'm sorry. I said 480 plus 600. Yeah, come on. Come on, Mr. Wagner. You got this. There we go, 1080. All right, number 9. Triangles ABC and A prime, B prime, C prime are similar figures. Determine the length of side B prime, C prime. So this is what we're looking for. We're trying to figure out the length of that particular segment. It says they are similar, meaning that these ratios, these proportions, are going to be the same from one to the next. So it's saying that they match up in this order. A here matches up with A prime, B with B prime, and C with C prime. So that means the length of AC, which I know here, and the length of A prime, C prime, should be in the same ratio as this one, BC, is to B prime, C prime. Therefore, for number 9, I can say that it should be that 13 over 5 should equal, this is larger to smaller, should equal proportionally 7 over whatever this one is. We'll just call it B prime C prime. That's the length of that segment. If I don't put any mark above it, that's what it's referring to. So from here, looks like we can cross multiply. We'll have 35 equals 13 times the length of B prime C prime. From there, divide by 13, and that should give you your final answer. It looks like we'll approximate this one. So this would be an exact answer. I'll give you exact answer and approximate answer on this one. So you could say 35 over 13. Don't forget your units. You could say that many centimeters. Probably not how you're going to tell somebody the length of a segment to use an improper fraction. So how many whole times does 13 go into 35? That'd be 2, and you'd be left over with 9. So you got 9 13ths. If you put that though into a calculator, let's do that quickly. And you just do 35 divided by 13, you get 2.69 approximately. So probably the way you're going to say it would be that right there, approximately 2.69 centimeters for your final answer for number 9. Number 10, we've got a right triangle right here. Right triangle ABC has one leg, length 5 inches, and the hypotenuse of length 13 inches. Part A, we're supposed to determine the length of the other leg. Let's call it X. I could call it whatever I wanted to, but I'll go with X. So remember, it's always leg squared plus leg squared equals hypotenuse squared. The hypotenuse always across from the right angle. The legs are always going to be the two shortest sides that come together to make the 90-degree angle. So there's the two legs making the 90-degree angle, hypotenuse across from that. So think of that first. Yes, a squared plus b squared equals c squared, but what do they stand for? A and b stand for the legs. C stands for the hypotenuse. Plug them in now. You've got 5 squared plus x squared equals 13 squared. A common error that I see is that students will sometimes just not think about it. They'll always plug in x for the hypotenuse, but sometimes you know the hypotenuse, which you do in this case, so you got to plug it in like that. So here we have 25 plus x squared. That's equal to 169. Subtract 25. Square root that bad boy. And you got your answer. The x should equal 12. And I was going to put centimeters, but it is inches. So 12 inches is the length of the other leg. So perimeter, now that I know that this is 12, for perimeter, I'll do this one. I'll do this in green. Perimeter, I'm just going to take the lengths of the sides and add them together. So I'm just going to take 12 plus 13 plus 5. 12 plus 13, that's 25, plus 5, that's 30. So part B, your answer is 30 inches. And then part C, go with black for this part. What's the area of this triangle? Area of any triangle is 1/2 base times height. These bases and heights, though, always have to be perpendicular to one another. So what are the base and the height of this triangle? Or they're these parts. They're perpendicular. They're the two legs in this case. So the base, generally we'd probably say it's the bottom, but you got to be careful. Sometimes the picture's rotated, so you can't always say the bottom, but it does work out in this case that it's the bottom. So you've got a base of 12 and a height, perpendicular height to that base is 5. Half of 12 is 6, and 6 times 5, you happen to get the same number as the perimeter. That doesn't happen very often, but it did in this case. This would be inches squared. Don't forget your units. Don't forget to put area in inches squared. Volume would be your units cubed. We'll get into some volume problems. Here's one right now. Number 11. So determine the volume of a sphere of diameter. Diameter, they're trying to trick you here, 16. The volume of a sphere, which is just one of the volume formulas that you'll need to know for the test. If you're one of my students, you got to know these formulas. I do intend to have kind of a matching section if you're one of my students for something like this, but we got to know at least how to match them up. We got to be able to recognize what formula is what. So the volume is going to be 4/3 pi r cubed. To prove that, I saw that proved in calculus for the first time. I was amazed when I saw that, and I was like, yeah, I actually understand that. That makes complete sense now that I know calculus. But to determine that without calculus, it's a bit more difficult, a bit more convoluted, I would say. But notice here the radius. So we just got to know this formula, but we know that the radius is half the diameter. So don't forget to, if they give you the diameter, we got to take that and divide it by 2. So 16 divided by 2. So we're going to plug in 8 for the radius. Now 8 cubed, 8 times 8 is 64, and that times 8 more. I got that right, 512, yeah. So 4/3 pi times 512, right there. I can think of this as being over 1, and then I can think of pi as being over 1. I'm just multiplying all the tops together and multiplying all the bottoms together. So 4 times 512, that should be 2048, and I've got that times pi on the top. I've got 3 times 1 times 1 on the bottom. That's 3. Is this number divisible by 3? Well, take the digits and add them up. 8 plus 4 is 12, plus 2 more is 14. 3 does not go into 14, so 3 does not go into that either. So this is a valid final answer, an exact final answer left in improper fraction form, but still a valid answer. This is volume, so it should be centimeters cubed here. So I don't think, though, that you're probably going to tell somebody that that's what your volume is. That really wouldn't make much sense to say that to somebody in the real world. So what would this be as a decimal approximation? Let's type that in. So we got 2048. Best to use the pi button on your calculator rather than just 3.14. That gives you a much better approximation. So that times that is that on the top divided by 3. I should get 2,144.66. So if it doesn't say what to use for pi, use the pi button on your calculator and you'll get the best approximation that way. So either one of these would be acceptable to me, but unless the directions specifically say to round a certain way, either one's okay, but I think this is probably the better answer in this case because it just makes more sense to say that it holds approximately 2,144.66 centimeters cubed rather than 2,048 pi divided by 3 centimeters cubed. Number 12. We're building a pier. So a pier, this is out in either the ocean or a large lake somewhere, something like that. The sketch shows the dimensions of the base of the pier for a bridge, or you could say a river too, I guess. You might be building a bridge across a river or a stream with semicircular ends. How many cubic yards of concrete are needed to build a pier 6 feet high? And so this is the way the pier looks like from the base. If I were to draw a picture of this three-dimensionally, you might have something like this. This is kind of the semicircle part of it. This could be that part of it here. So here's the semicircle part, and so your pier might look something like that. And you're wondering how much concrete does it take to fill that up to make sure that it's not going to break and actually be totally filled up. Engineers would be doing stuff like this. If you're the one purchasing the concrete, you need to know how much concrete you need to buy so that the trucks you have coming out have enough to actually construct the pier. If you didn't have enough concrete coming out and then half of it dried up and the other half wasn't there, and then that would be brittle because it's not all sealed together and didn't all dry at the same time. Not good. We got to know exactly how much concrete to bring out to make this pier first time around. So let's see what we got. I'm going to figure out, this is it's kind of like how many cubic yards. This is a volume problem. But what we really need to find is the area of this thing first. So it's kind of like this. It's kind of like if we find the area of the base, which is this whole thing here, which is the same thing as this whole thing here, just three-dimensional view of that. If we find the area of the base and multiply it by the height, we will know how much that takes to fill it up. And so the area of the base, this B part, notice here I have a half circle and I have another half circle. If I put them together, I'm going to get a whole circle. And what's the radius of that whole circle? It's 4.5 feet. And so the capital B part, the area of the base, is going to be the area of the circle plus the area of, I see a rectangle right here. So if I take the rectangle here, area of that plus the area of the circle, which is formed by the two half circles coming together here and here, then I will have the area of that whole base, and I'll just need to multiply that by the height to get how many cubic yards of concrete I'll need. But it does say cubic yards, and my dimensions here are given in feet, so I'll have to consider that at the end. Alright, so I have the area of the rectangle. So the area of the circle, a circle is just pi r squared, a rectangle is just base times height. So here you're going to have 4 times, or pi times 4.5 squared, and then the base of the rectangle is 14, and the height perpendicular to that base there is 9. So we have 14 times 9, 4.5 squared. Let's check it out. Let's see what we got. 4.5 squared is 20.25. So I'll write it like this right now, 20.25 pi. That would be an exact value. And 14 times 9, that would be 90 plus 36, which would be 126. Now approximating this, I think at this point would be a good idea to do. So I'm going to take this times pi and take that plus 126. And I'm going to use more decimals than I might normally at this point. So 0.6173 if I round that off. 0.6173, I think that was 189 for the decimal. Yep. So I got 189.6173. This is feet cubed. This is not yards cubed, however. So you got to think about, how does that vary? How is that different? So this is in terms of volume. So if I considered this to be a 1 yard by 1 yard by 1 yard box, how much cubic feet would that be? That would be 3 feet by 3 feet by 3 feet. And so it looks like 1 cubic yard, which is what I have by doing 1 times 1 times 1, length times width times height. 1 yard cubed is going to equal 3 times 3 times 3, or 3 cubed, which is 27 feet cubed. So every 1 yard cubed is equivalent to 27 feet cubed. So with that in mind, we can say this. Therefore, you have 189.6173 divided by 27. We got to do that to get the number of yards cubed. So I kept my answer in the calculator there. This is going to be even better than that value right there. If I divide that by 27, that should give me the best possible answer. So it looks like about this many yards cubed. And I just realized I forgot to do something. So this, I got to do one more thing. This was the area of the base. We forgot to multiply this by 6. So this is not feet cubed yet. I'm sorry. This is feet squared. So I'm not really ready for this yet. So my sincere apologies on that. That was no good. What I do want to think of this now is the volume is going to be the area of the base times the height. It's not a prism, I know, but if you find the area of the base, even if you take kind of a strange shape like that where you have this semicircle here and here, put it together, it's still the same idea, still the same concept. So the area of the base times the height, which we know is 6 feet. We're going to plug this in right there. It's approximately 189.6173 times now the height, which would be about this much. So this, I had gotten that by dividing by 27. I'll multiply by 27 to get back to where I started. Okay, so I've got that value times 6, which is 1,137 points. I'll go with 4 decimal places still, 0.7035. Okay, so 7035. Now I can do what I was doing before. That should work now. So I've got this divided by this should be my number of, this is feet cubed, this should be my number of yards cubed now. So I take that value, divide it by 27, and that looks better. So I've got 42.14 rounded off to 2 decimal places. That would round off to that right there. So this would now be yards cubed. So you're going to call up your concrete truck guys. They're going to come with 42 and some change cubic yards for you, and they'll pour that into the mold or the form that you have to make that base for the pier. It'll all dry together, and so it'll all be strong and sturdy at that point, rather than you messing it up and ordering the wrong amount, not getting enough, and having it watch it half of it dry and then the other half dry, and then you got to build the whole pier again, and no good at all. All right, 13. This is going to be the last one, I believe. Is there one more that we're going to go over? No, this is the last one that we're going to go over for right now. I may do part 2 later, but for right now we're just doing 9.1 to 9.4, those lessons. So the volume of a pyramid, this is another formula we need to know. We did pyramid here, it looks like, and we're kind of doing prism-ish, this B times H, but this isn't exactly a prism. We got to know all those volume formulas though. So prism, cone, cylinder, sphere, box is a special type of prism, rectangular prism. I feel like I might be forgetting something. Just check your notes out though, make sure you got all those formulas down. Make sure you know the area formulas as well from 9.3. But what's the volume of a pyramid? We did a little demonstration on one of the videos where we saw that 3 pyramids filled up a prism with the same base and height. So we have that the volume is 1/3 times the area of the base times the height. And so 1/3 times B is the area of the base. What kind of shape is this base right here? Well, to me it looks like it is a rectangle. And so it is how long? That's 7 feet right here from here to here, and it's 4 right here. That's my capital B. That's the area of the base. And so I'm doing 7 times 4. And then what's the height? Straight up and down height from the base up to the tippy top, the vertex of the pyramid is 12. So from here, I've got 1/3 of 28 times 12. It's all multiplication. Commutative property says I can multiply these in any order. 1/3 of 12 would be easiest to do first. 1/3 of 12 is 4, and 4 times 28 would be 112. So this would be 112 feet cubed. And then just one more reminder about this. If you go to the problems on these pages here, 554 to 556, if you're one of my CTM students, you look in your textbook, check those out. If you feel like, I kind of understood what you did there, Mr. Wagner, but I feel like I need some extra practice, go to those pages, check them out, try them, all the answers for those, even the evens. Even the evens are in the back. Yes, it's true. Even the evens will be found in the back as well as the odds. So check your work as you go. If you want to try those for extra practice, be ready for that Chapter 9 test coming up soon. And you know what? Hey, whatever day it is for you, whatever time of day it is for you, have a good rest of your day. Have a good day tomorrow. And I will see you guys later. Bye-bye.